So I want to start this lesson by focusing in on these where we convert decimals to percents or percents to decimals. And let's start by just understanding a phrase, giving 100%. Like if you're a player and your coach says, hey, you're doing great in practice, you're giving 100%, what does that really mean? Your all. Your whole self, right? Your whole. So if you're talking about 100%, you're talking about one whole, like as in 1.0, right? The whole. If you're only giving 99%, it's not one whole, right? How much would it be as a decimal? It would be 0.99. That's almost one whole. That's like 99 cents. It's almost $1, right? So if we think about the phrase that we use, that giving 100% means giving your all, that means that you're giving one whole, right? You'll be able to conclude which way to move your decimals. So if we look at point 2, where they're asking us to convert this decimal to a percent, okay, is point 2 close to one whole, or is it closer to 0? It's closer to 0 than one whole, right? So it's not going to be close to 100%. So if I move this over 2 spaces, that'll be 20%, right? You move it over 1, 2 spaces, that will be 20%. How about number 22? I need to convert that decimal to a percent. So from a decimal to a percent, you move 2 spaces to the right. And we might as well jot that down somewhere. Decimals to percents, let's box this in, and we'll put move decimal to left or right? Anybody paying attention? Right. Okay, sorry about my sloppy handwriting, but write that down somewhere. Decimals to percents, you're going to move 2 to the right. So that means if you go backwards, percents to decimals, where are you going to move the decimal to? To the left. Okay, we got that. So let's stick with these first ones, decimals to percents. So on every single one of these, you're going to move 2 to the right. Ivan, so what does this become as a percent? 13%, Ivan. Got it? Make sure you jot that down. All right, let's try another. Number 22, what's that going to be? 5%, that's right. 1, 2, it becomes 5%, right? Now, don't think that when you convert a decimal to a percent, there's no longer decimals. Sometimes there are decimals within percents. For example, 25. I want to move it over 2 spaces, and the decimal's right here, but now it's a percent, so it's really a 0.2%. I mean, that decimals do exist within percents as well, right? What does this mean, 0.2% chance? Like if they say there's a 0.2% chance of chewing bubble gum, right? That means that it hardly happens. It's less than 1%, right? That's not a real statistic, by the way. Anyway, so on all of these, you're just moving them over. What's 23 going to be as a percent? 12%. How about 26? What's that going to be as a percent? 1.37%, right? Okay. And they do exist. If you invest money in the stock market, there'll be at times you'll be making 1.37% interest. How about 0.25 as a percent? 25%. Hope everybody's following along. By the way, you're going to have to do this on the quiz Friday. How about number 24? 47? 47.5? How many spaces do I move it? 2 to the right? So here's my decimal. I'm going to go 1 space, 2 space. 4.75%. That reminds me of when I first bought my house, I ended up getting the interest rate on the house at 4.75%. It really does. You really do have decimals within percents in the real world out there. 27, what's that? 95. That's like saying 95 cents, it's almost $1. 0.95, it's almost 100%, which is 95%. Here we go. So we finished that section, and we said, well, if converting decimals to percents, we move it 2 spaces to the right. Going backwards, percents to decimals, you're going to move 2 spaces to the left. So let's write that down right there. Move 2 to left. I probably should have said move the decimal 2 to the left. So if you look at these, you're probably thinking, what decimal? These aren't even decimals. These are percents, right? Every number has a decimal, even though they don't show it. Where's the decimal at on the 7%? It's right here after the 7, right? That's like a 7.0%. I want to move it 2 to the left. So what's my decimal going to become? 0.07. And it's okay to put a 0 out in the front if you want. Okay? Or you could just say 0.07. How about number 32? What's that going to be? 0.075. There you go, 0.075. How about number 35? What's that going to be? 0.8 or 0.80 if you want. You don't have to. Or you could even say 0.8 or 0.80. But that's your answer from a percent to a decimal. Okay, I want to pause it right here. If you're watching this for the first time at home, pause it and try to do the rest, and then we'll play in a couple of seconds with all the answers. So there are the answers. I hope everybody got those answers right. You're just moving the decimal 2 places to the left in this case. So 34 is kind of confusing. The decimal was already there in a percent, and you move it 2 to the left. So you have to fill in this empty spot with the 0. So it's really a 0.000 with the 6. 0.000 with the 6. So there's your answer. I hope you guys got that. If you're struggling, please watch the video. You're going to have to do some of these things on the quiz Friday. Let's move on to this last portion where we're converting the fraction to a decimal and then to a percent. Now, some of us are able to visualize what 1/4 looks like, and we see that that's actually 25% of a pizza or 25% of a gas tank. But another way of doing it from a fraction to a decimal is to actually divide, right? You put the top number inside the division box, and the 4, give me a second. Man, my Apple Pencil's failing me. And the 4 on the outside. So 4 times what gets you close to 1? It doesn't work. You're going to put a decimal and a 0 so it looks like a 10. And then you would say 4 times 2 gets you close to 10 by giving you an 8. And when you subtract it, 10 take away 8 is 2. Okay? Which means that you need to add a 0 and then drop a 0, and that becomes 20. Then you think 4 times 5 will get you the 20. So the decimal that we added to get a 0 is now going to go up here in front of the 2. So that's how we end up with the 0.25. An easy way of doing this is with the simple calculator. Go 1 divided by 4, hit equal, it'll give you 0.25. But anyway, we converted the fraction to a decimal. And now let's convert that decimal to a percent. What do I do to convert a decimal to a percent? Move it 2 to the right. Okay, so the percent will be 25%. Let's try number 38. 7/10. You could put the 7 inside the division box and the 10 on the outside and put a 0.0, make it look like a 70, or the easier option, check it out, guys. If you read this fraction correctly, it says 7/10, right? 7/10. And if you read the decimal number 7/10, that would be this one right here. Because 7 is in the 10th position, right? If it were a 7/3, then it'd be 73 hundredths, 73 over 100, right? But right here it's in the 10th position, so you read this as 7/10, you read this as 7/10. So if you don't like this trick, you could actually just set up what we did here, do the long division. 10 will go into 70 7 times. The decimal goes right there, so you get that same decimal anyway. So 7/10 is really the decimal 0.7. Let's convert that to a percent. What's that going to be? 70%. Okay. How about 39? Before converting the fraction to a decimal, yeah, you could use long division, but before doing that, why not reduce? They're both even numbers. We could at least reduce by 2. Or could we reduce by any higher number? What do you guys say? what bigger number than 2 could you reduce 24 and 30 by? 6, right? Now let's say you didn't understand that, right? You don't know your multiplication tables that well. You could reduce by 2, and that'll give you 12 over 15, and then you could reduce by 3, and that'll give you 4 over 5. There's your final fraction, okay? Or you could have, from the beginning, said, hey, 6, 24 divided by 6 will give me 4, 30 divided by 6 will give me 5. So there's your fraction, reduced fraction. Now let's change it to a decimal. Now we could change it to the denominator 10, so we could read it as something tenths, so we could change it to the decimal. Or we could actually do long division. What do you prefer? Long division? Or change it to a denominator of 10? Anybody? Who's awake? Say something. Say again? What do you want to do? You don't know. Oh gosh. I'm going to pause it till somebody tells me. So if you're going with long division, you're going to put 4 inside the box, the 5 on the outside. Of course, 5 times what gets you close to 4 without going over? It doesn't work. So that's why we put a 0.0 to make it look like 40. And of course, this decimal that you added is going to go up here. And 5 times what gets you 40? 5 times 8 gets you 40. So your decimal is 0.8. 0.8. Now, if you want to convert this decimal to a percent, you're going to move it 2 spaces over, giving you 80%. So those are your 3 answers. The fraction 4/5 changes to 0.8, and 0.8 changes to 80%. Number 40, 9/10. Could we convert that to a decimal? What's the easiest way to convert this to a decimal? Long division? No, just listen to it. How would you read that fraction? It reads 9/10. So that'd be 0.9, because 0.9 is read the same 9/10. After all, this 9 is in the tenths position. Okay? And if I were to change this decimal to a percent, what would it be? 90%. Excellent. Hopefully everybody gets at least a 90 on the first quiz. Number 40. This one right here, how would you read this? 7/100ths. That's how you would read this fraction with the appropriate name, right? 7/100ths. So since this is read 7/100ths, that's the actual decimal itself. 7 in the hundredths position. This is the tenths position, this is the hundredths position. So there's your decimal, 7/100ths. As a fraction, or as a percent, what would it be? 7%. If you move it over 1, 2 spaces, that'll be a simple 7%, not 70%, just 7. This last, or not the last one, but we're getting close to the last ones. On these, yeah, to change it to a decimal, you could do 13 on the inside of the division box, 25 on the outside, but that doesn't even sound fun unless you have a calculator. Just do 13 divided by 25. But another option is, if you could change this to 100, then you'd be able to read the fraction as something hundredths, which means you'd be able to write the decimal in the hundredths position, right? So how about we manipulate this 25 and make it 100? How could I do that? Times it by 4, times it by 4. So my new fraction would be what? Definitely 100 on the bottom, but what would be up on top? It's kind of like doing a distributive property problem. 4 times 10 is 40. 4 times 3 is 12. 40 plus 12 is 52. So I hope you guys know how to manipulate it. How do you read that fraction now? 52 over 100, which means that it's the decimal what? 0.52, right? This is 52 and it's in the hundredths position. Okay, and now for the percent, what would the percent be? 52%. There you go. How about we do the same for 42? Let's convert that 50 to 100 by doing what? Times 2 times 2. What do we end up with? 18 over 100. What's the decimal going to be? 0.18. That's really the 1800ths, right? Because it's in the hundredths position. This is also read 1800ths. How about as a percent? 18%. All right, we're starting to wake up. Good. This last one's interesting. I put a little star right here because something weird happens. Let's actually do the long division here. I put the 5 on the inside of the division box, the 9 on the outside, and we're going to put a 0.0 to make it look like 50. What 9 times what gets us close to 50 without going over? So we have a 5, right? That'll give us a 45. And when we subtract, we'll get 5. And then we're supposed to add a 0 and drop a 0. So we end up with 50 again, which means that we'll have a 5 again, which means we'll get 45 again. And you'll have 5 left over again. And then you add a 0 and drop a 0. What's going to keep happening? Repeating. So this decimal, what do I mean by decimal? Here's the decimal that I added. It needs to go up right here in front of the 5. This decimal, 0.55, it repeats. So you could put it as 0.55 and then the line on top of the second 5, or you could even do this. You could put 0.5 with the line repeating on top of the 5. So here's your decimal. It goes on forever. It's not irrational, though. It makes sense. Why does it make sense? Because you could actually see the fraction here, 5 over 9. It's like taking a chocolate bar, dividing it into 9 pieces, and giving somebody 5 of those pieces. So we understand the fraction 5/9. It makes sense. As a percent, what would the percent be? 55.5%. And that 5 is repeating. So you could say roughly 56% if you wanted to. Okay. Remember the 0.555 and it's repeating. You'd move it over 2 spaces to get the percent. That's why it's 55.5%. Or you could give an approximation of 56%. Let's do this last one. But you know what? Let's eliminate the negative square root of 10. Let's eliminate that one. We need to put all these different numbers in order. We have different types of numbers here. Just to review, what kind of number is this if I asked you to classify it? The nice number 4. Natural. How about the negative 3? What would that be? Integer. What would the square root of 17 be? That's irrational. It's a crazy decimal. This is an integer also. What's this guy? Negative 7/2. It's rational. It's definitely a ratio. It's a fraction. Any fraction or decimal is called what? Rational. Good. Okay, so we're definitely going to have classifying on the quiz Friday. And I think we're going to have this question as a bonus question where I ask you to list them in order from least to greatest. So the best way to do this is to actually draw a number line, because whatever number lands furthest to the left will be less, and whatever's on the right side will be greater. So let's just put even though there is no 0, I'm just going to put a 0 right here. I want to put the 4 over here. I want to put the negative 3 over here. Right? So far I've done 4, I've done negative 3. Where would negative 2 be at? Between the negative 3 and the 0, right? So let's put that negative 2 right there. What else could we do? How would we plot this guy? Turn it to a decimal, right? What's 7 divided by 2? What's half of $7? 3.50, right? So negative 7/2 really becomes negative 3.5 or negative 3.50. So that would be somewhere right here, right? Negative 3.50 to the right of negative 3. To the left of negative 3. Where would negative 3.25 be at? In the middle of?
Negative 3 in the middle of negative 2.
Yeah, right in the middle of negative 3 and negative 3.5. Okay? Right in between negative 3 and negative 3.5. Okay? So here's like, you owe somebody $3. You owe somebody $3.25. You owe somebody $3.50. So it'd be right in between. Okay? Which one's the only one we're missing? The square root of 17. I don't know what that is unless I think about perfect square numbers. So where would the square root of 17 be in terms of perfect square numbers? It's going to be really close to which perfect square number? 16. The square root of 16, right? Which the answer is 4. Is the square root of 16 a little bit less than square root of 17 or a little bit greater? Greater. I should have asked it the other way around. Is the square root of 17 less than the square root of 16 or a little bit greater than the square root of 16? greater. So this is really about what? 4.1, a little bit greater than the answer to the square root of 16. So where would the square root of 17 be at? The square root of 17 would be over here a little bit more than 4. Square root of 17 right there. So if they're asking you to list it from least to greatest, it's a great idea to do a number line. That way you'll be able to do so. Let's start with the negative 7 halves. That's the first number. That's the smallest number. That's the negative 3.5. Then we have the negative 3. Then we have the negative 2. The 0 wasn't even on the list, but we do have the 4 and then the square root of 17. So those are the numbers listed in order from least to greatest. I hope this helps. I hope you guys review these videos that we've been doing on this worksheet because all this stuff comes out on the quiz Friday.